Hello, here's part 4 of section 5.4, 5.5 notes, log properties. So sometimes it doesn't just fit the other ones, but when you have logs, you can use log properties to make things simpler. So for example 4, it's not quadratic in form, and I can't write them with the same base because of that 1, but I can use log properties because this is the same thing as log base 6 of x plus 4 times 3 minus x. When you're adding two logarithms, that's the same as multiplying the arguments. Now I can cancel, because there's only a single logarithm, cancel the logarithm out by 6ing it up on both sides. Then we get x plus 4 times 3 minus x equals 6. Distribute the left-hand side, we get negative x squared. Negative x plus 12 equals 6. So I did distribute and combine like terms at the same time there. It's okay if you don't. Let's subtract 6 from both sides. Negative x squared minus x plus 6 equals 0. Divide by negative 1 to make life easier. X squared plus x minus 6 equals 0. That's x plus 3. X minus 2 equals 0. So x equals negative 3 or x equals 2. And again, you should plug this in and make sure that it works. And both of them do work, so they both are your solutions. Now, what do we do for part B? Well, the first thing I'm going to do is subtract the log base 2 from both sides. And now that we're subtracting logarithms, that's the same as dividing their arguments. So that's log base 2 of x plus 3 over 6 minus x equals 3. 2 it up on both sides. So you get x plus 3 over 6 minus x equals 8. Multiply by 6 minus x on both sides. So then we get x plus 3 equals 48 minus 8x. Add 8x, add 8x, subtract 3. We get 9x equals 45. Divide by 9, we get x equals 5. Then you just have to check and make sure that it works, and it does. So x equals 5 is our solution. Then C. This one is tricky because they don't have the same base to start with. But if you remember, and I'll do this off to the right-hand side over here, log base 4 of t plus 1, I can rewrite that as log base 2 of t plus 1 divided by log base 2 of 4 using our change of base formula. So then this is log base 2 of t plus 1 divided by, well, log base 2 of 4. 2 to what power is 4? Well, 2. Well, I don't like writing as division. I'm going to write it as 1/2 log base 2 of t plus 1. So what this green writing off to the right is saying is that we can replace log base 4 of t plus 1 with 1/2 log base 2 of t plus 1. So we get 1 plus 2 times 1/2 log base 2 t plus 1 equals 2 log base 2 of t. Well, there, the 2 cancels out with the 1/2. And then I'm going to use our power rule on the right-hand side to bring the 2 up as an exponent. So we get log base 2 of t squared. Now I can add the log base 2 of t plus 1 to both sides. We get 1 equals log base 2, and because I'm adding them, you multiply the arguments, t cubed plus t squared. And then we can 2 it up on both sides. And get 2 equals t cubed plus t squared. Now, this is a cubic equation, not a quadratic, so we can't solve it like with the quadratic formula or anything like that. And actually, this cubic equation, I'm not going to use anything to solve it. I'm just going to do it by inspection. So 2 equals what number cubed plus what number squared? Well, if you just play around with the numbers for a little bit, I hope you see that 1 cubed plus 1 squared, which is 1 plus 1 equals 2. So that implies our answer is t equals 1. And that's it for this part of the notes.